Okay, on this video we are going to solve a homogeneous differential equation. In this case it's the same example as before, so we already know this is an homogeneous differential equation of second degree. But here they are giving us an initial condition. Remember, if they are giving us an initial condition, that means that we have to calculate the constant. Okay, now the formulas that we discussed. W is equal to y over x, and the differential of y is equal to w differential of x plus x differential of w. I'm using these formulas because here is in the differentials, alright? Okay, so let's do the variable change. Sorry, here y is equal to w times x. So you are going to replace the values of y. So it's going to be x squared plus y squared. In this case is w times x squared, and then differential of x plus x squared minus xy, and here is w times x. And then the differential of y, you are going to replace this value, times w differential of x plus x differential of w, and that is equal to 0. Now, here you have to be very careful here, because here the differential equation is x and y. And here we have replaced the differential equation. Here, the differential equation is x to w. So it is a different differential equation, but it's supposed that this one is supposed to be variable separable. When you solve this differential equation, you just have to remember to bring back the variable change. All right. But let's continue. Here, what happens here is that you have x squared plus w squared, x squared differential of x, plus here x squared minus x squared w, and then times w differential of x plus x differential of w equals 0. Now let's do some factorization. Here I can factorize the x squared, and also I can factorize here the x squared. So let's do it. Here x squared times 1 plus w squared differential of x plus x squared here, and then 1 minus w, only w, okay, and then w differential of x plus x differential of w, and then equals to 0. What I'm going to do is to divide everything by x squared. And the reason is that this x squared is going to cancel, and 0 divided by x squared is 0. Okay, so let's continue over here. So it's going to be 1 plus w squared differential of x plus, here is going to be 1 minus w, and then w differential of x plus x differential of w equal to 0. Now let's do the multiplication on this part. So here you are going, this is the same, 1 plus w squared differential of x. Let's do the multiplications, okay, because I suspect that something is going to cancel. So let's do, or maybe not, okay, differential of x plus w squared differential of x plus, and here be careful, 1 times this and this, so it's going to be plus w differential of x plus x differential of w, and then this times this minus w squared differential of x, this times this, and then this times this is going to be minus wx differential of w, and then equal to 0. Okay, now anything cancels? Yes, as a matter of fact, this and this cancels. Okay, anything else cancels? No, I don't think so. Now let's do some factorization. Let's factorize the differential of x, and that's it. And that's it. So what you get here is, from the differential of x is going to be 1 plus w differential of x from here and here, and then the differential of w from the differential of w is this one and this one. Okay, so it's going to be plus x minus wx differential of w equals 0. Actually, we can also factorize the x, so let's do it. So it's going to be 1 minus w x times 1 minus w. Here you can factorize the x and x. Okay, so that is the new differential equation. Now let's do the following. Let's try to separate the variables because the theory says that this is supposed to be a variable separable. So I'm going to pass this to the other side. 1 plus w differential of x equal to here. Into the other side is going to be minus x, but the minus I'm going to introduce it here. So it's going to be x times w minus 1 differential of w. Okay, so the x has a division and this has a division. So it's going to be 1 over x differential of x equal to w minus 1 over w plus 1 differential of w. And you can see here we have a variable separable differential equation because here you have only x and here you have only w. So it happens. So let's solve that differential equation. So what we have to do is to apply integrals on both sides. So the integral of this is going to be the natural logarithm of x equal to the integral of this. Let's do the following. W minus 1 over w plus 1 differential of w. I separated the minus 1, is the same. What I'm going to do is this, plus 1, and then to compensate that, also I add minus 1. That is actually a trick. Why I'm doing that? Because with this, I'm going to get this, the same denominator, and this is going to be minus 2. But it's the same because 1 minus 2 is equal to minus 1. So that is just for solving this integral. So it's going to be the integral of w plus 1 over w plus 1 differential of w, and then minus the integral of 2 over w plus 1, and that's it. And here what we are going to get is, on the left is the natural logarithm of x equal to this one, this cancels, so it's going to be just w, and then, oh sorry, I forgot here the differential of w is going to be minus 2, the natural logarithm of w plus 1 plus the constant. Don't forget the constant when you make the integrals. Okay, so that is the implicit solution, but that is the solution of this differential equation, and that is not the original differential equation. Here the differential equation is w as a function of x, but we really need is y as a function of x. So what you have to do is to bring back the variable change. So many students bring back variable change. A common mistake from the students is that they finish here and that's it, and they forget to bring back the variable change. So don't do that. Don't forget to bring back the variable change. So what you have to do is actually replace the value of w, y over x. So it's going to be here is still the same, the natural logarithm of x equal to w, but w is equal to y over x minus 2, the natural logarithm of y over x plus 1. Plus the constant. So that is the implicit solution. Okay. From there, I don't think we can clear the y, so I'm going to leave it like that. But we have the constant. Because this problem is giving us the initial condition, let's calculate the constant. So it's very easy, engineers. So from here, I'm going to replace just the values of that. So x is equal to 1, while y is equal to 0. So it's going to be the natural logarithm of 1 equal to 0 over 1 minus 2, the natural logarithm of 0 over 1 plus 1 plus the constant. Now the natural logarithm of 1 is equal to 0, and here is the natural logarithm of 1, so this is 0, and this is also 0. So the constant happens to be just 0. Alright, so the solution is just the natural logarithm of x equal to y over x minus 2, the natural logarithm. Here I'm going to do the common denominator, y plus 1 over x, and the constant is 0. Sorry, here is x, y plus x over x Maybe we can apply the exponentials, but still is the same solution. We can apply the exponentials. It's going to give us a nicer result, but it's still the same. So this is implicit specific solution. Implicit specific solution. So engineers, this is the way to solve homogeneous differential equation. Again, as a summary, first identify that it is homogeneous. If it is homogeneous, then you apply this variable change. You should get a variable separable differential equation like this. And because it is a variable separable differential equation, then you can solve it. But when you solve it, don't forget to bring back the variable change. And here is the variable change back. And this is the specific solution. Alright, see you in the next video.